Okay, just for the sake of this problem, what I'm going to do is I'm going to change this to a 2. It's going to make it much nicer to work with. So what I would do is I'd first put the right side of this, which is currently in rectangular form, in cis form, which I believe was 16 cis negative pi over 3. Again, I'd add 2 pi k onto the end of that, just so I could take care of all possible solutions. And now what I would do is take the square root of both sides. Okay, so the square root of 16 is 4. And what do I do with that 1/2 with the angle? Multiply. So I get negative pi over 6 plus, so it would be 6 pi k over 6. And now I could come up with my my roots, if you will. Okay, so again, if this is a 2, then I'll have k equals 0 and k equals 1. So I'll have 2 roots, which z sub 0 would be 4 cis negative pi over 6, and z1 would equal 4 cis, what is that, 5 pi over 6? Okay, cool. So there are my solution. Those are my roots, right? In order to graph this on an Argand diagram, I don't know the pronunciation of that necessarily, I need these in rectangular form. Those need to be in rectangular form. So if they were, let's just sketch the first one here. Here would be z sub 0, radius of 4, angle of negative pi over 6. What would my values be here and here? Which one would be 2, Ben? This side? Well, it would be negative 2, but you're right. Right? And then this would be 2 root 3. Okay, so technically speaking, z sub 0 would equal 2 root 3 minus 2i, and we would plot that on the Argand diagram. So I would go over 2 root 3, which is going to be further out than 2, and down negative 2i. So it'd be about there. Okay. That would be z0. Okay, for full credit, you would need it in this form. If it were a problem out of 6 points or whatever, I'd probably give you a 5 if you just put it in the polar form, the cis form, and didn't translate it. The second one, z sub 1, would still be 4 as the radius, but now I'm going to sketch over here. What quadrant would that be in? Third quadrant. 5 pi over 6 would be right here. So there's your radius, or your modulus. This angle would be pi over 6, and therefore this would be 2, and this would be negative 2 root 3. So how would I write z1 in rectangular coordinates? Negative 2 root 3 plus 2i. Okay, and those are very closely related, obviously, due to the fact they have the same x and y, or the same real and imaginary, except they're just now, oops, that was poorly drawn, in opposite quadrants. There you go, there's z1. So then the question becomes, okay, what if it's not a nice unit circle angle like pi over 6? So what if I did this? Is that the correct original? Yeah. Is that right? Okay. So now this equals 16 cis negative pi over 3 plus 6 pi over 3k. And I take that to the 1/4 power. Well, now z equals 2 cis negative pi over 12 plus 6 pi over 12k. So that becomes, well, now what do I do with this? Well, you'd get 2 cis, and I'm just going to do this for 1 point, negative pi over 12. Gross. Anybody know the values for x and y for the angle pi over 12? Neither do I, off the top of my head. Right, but we can use an identity here. Let's first put this on the unit circle, so to speak, and find out where it would be. Okay, hypotenuse or modulus of 2 angle of negative pi over 12. Not quite sure what that would be. But, and this is where on an IB exam, we would use something like this. Y. Yeah, to make things more complex. Or if I know, let's say right here, if I know pi over 6, I could find pi over 12. Right? Double angle formula. So let's find at least the cosine. Let's find the cosine here, and then we'll go from there. So let's solve for cosine theta. What would I do? I'd add 1, I'd divide by 2, I'd take the square root. So if I add 1, I divide by 2, I take the square root, I get 2 possible answers. That equals cosine theta. So what if theta equals pi over 12, right? What would 2 theta equal? Pi over 6. So technically speaking, the cosine of pi over 12, oh boy, lost it. The cosine of pi over 12 we could find here in a moment by plugging in right here pi over 6. Okay, so let's go ahead and roll through that. What would that be? Well, plus or minus the square root of 1 plus, what's the cosine of pi over 6? So what was it? Square root of 3 over 2. Okay, and we're going to divide that by 2. Okay, so let's keep going. Let's do some simplifying. It's going to be ugly. It's not going to be pretty if it's not a unit circle number. But what I'm going to do is I'm going to split this up a little bit. Go for it. I got you. That would be. Hold on. If I split this up like this, would you agree that the square root of 3 over 2 over 2 is the square root of 3 over 4? Right? And 1/2 is the same as 2 over 4? So would you agree that then I could simplify, what's the square root of 4? 2. So I could have 2 plus the square root of 3 over 2 is equal to the cosine of pi over 12. Gross. Okay, which one of those, like we had above, is going to be in the fourth quadrant? Well, the positive one, right? So this value here would be the square root of 2 plus the square root of 3 over 2. And then what's cool is the sign. The sign will always be the same thing, except a minus in between. And of course, that would be a negative value there. So this point, c sub 0, 4 of which you're supposed to find, would be square root of 2 plus square root of 3 over 2 minus the square root of 2 minus the square root of 3 over 2i. Yuck. That would be the coordinates of z0. Then we would have to find z1, right, which would be like here, and z2, which would be here, and z3, which would be here. So I just did 1/4 of that problem. Okay, but you can use double angle in order to solve that. But I'm going to put that up there too. Okay, so this was supposed to be a 3-minute problem, of which it wasn't. But you'll see down here in this quadrant, we had a positive followed by a negative. Up here, we'd have a positive followed by a positive. Of course, the y down here would be the x, and the x down here would be the y. Over here, we'd have a negative positive, and down here, we'd have a negative negative. Okay, so you can take what you found and duplicate that in the other 3 quadrants.